Hello students, last time we have completed methods of preparation of aldehydes and ketones. Now we are going to start methods of preparation of carboxylic acid. Now here, when first method we are going to see is from nitrides and amides. Now we know that what is meant by nitrides. When alkyl or aryl group is attached to CN group, then it is called as nitride. Either it is alkane nitride or aryl nitride. Now here we can prepare aliphatic carboxylic acid and aromatic carboxylic acid by using this method. Here when alkane nitride or alkane nitride, when it undergo acid hydrolysis, gives corresponding carboxylic acid. Here first formation of amide takes place and this amide is then undergo hydrolysis in presence of mineral acid like hydrochloric acid or sulfuric acid to give carboxylic acid. Now we are going to see first general reaction. This is RCN, that is alkane nitride. When it undergo hydrolysis, then addition of HOH, that is H2O, takes place across this triple bond to form RCOH double bond and H. That is addition takes place across this triple bond and OH group get attached to this carbon atom and hydrogen get attached to this nitrogen atom. Now this undergo tautomerism or it undergo rearrangement, and here this hydrogen atom gets shifted, that is breaking of this this OH bond takes place, and here this H plus ion is removed, and here this OH bond gets, or these electrons get shifted in between carbon and oxygen atom, and then this double bond shifts on nitrogen atom to form, and then this hydrogen atom get attached to this NH to form RC double bond O NH2. This is amide. When CO group is attached to NH2, then it becomes amide. Now here, this amide undergo acid hydrolysis. That is, addition of H2O is carried out in presence of this HCl to form RC double bond O OH plus NH3. This is ammonia. This is carboxylic acid. This reaction can be written like this. Now this is RCN. When this alkane nitride or alkane nitride, when it is treated with H2O and HCl, then it is converted into RC double bond O OH plus NH4Cl. This is direct method. That is, this intermediate is formed and it is directly converted into this carboxylic acid. In this way, we can prepare carboxylic acids using nitrides. Now here examples. This is ethane nitride. CH3, C triple bond and ethane nitride. When this ethane nitride undergo hydrolysis, then here first formation of amide takes place. That is CH3, COH double bond NH. This compound undergo isomerism or tautomerism, and then here this hydrogen or this bonded electron of OH group get shifted in between this carbon and oxygen atom, and then this electron shifts on nitrogen atom, this hydrogen atom free H plus ion get attached to this nitrogen atom to form CH3 C double bond O NH2. This is amide, acetamide. And this acetamide then undergo acid hydrolysis. That is, in presence of dilute acid, it undergo hydrolysis to form CH3 C double bond O OH plus NH3. This is acetic acid. In this way, we can prepare acetic acid by using ethane nitride or acetonitride, ethane nitride or acetonitride. Then this reaction can be written like this, or this hydrolysis is directly can be carried out like this. This ethyl nitride, when undergo hydrolysis in presence of dilute HCl, then here formation of CH3, C, double bond O, OH plus NH4Cl. Now here it is acetic acid, and this acetic acid is formed by using direct acid hydrolysis of ethyl nitride. Now we are going to see second example, that is C6H5Cl. This is benzonitride or aromatic nitride. When this benzonitride undergo hydrolysis, then first you will get C6H5COH double bond NH, and then it undergo isomerism, that is tautomerism. Then these bonds get shifted in between this carbon and oxygen atom. This pi electrons get shifted on nitrogen atom, and this hydrogen atom get attached to this nitrogen atom to form amide C6H5 C double bond O NH2, and then it undergo hydrolysis, that is addition of H2 is carried out in presence of dilute HCl to form C6H5 C double bond O OH plus ammonia. This is benzoic acid, and this is benzamide. In this way we can prepare aliphatic as well as aromatic carboxylic acid using nitrides and amides. Second method for the preparation of carboxylic acid is by using acyl chloride or acyl anhydride. Now here we are going to see first by using acyl chloride, that is RC double bond OCl. When this acyl chloride undergo hydrolysis, that is addition of water molecule is carried out, then formation of RC double bond OH plus HCl takes place. Now here from this HOH, that is water molecule, removal of this HCl takes place, and this OH get replaced by this chlorine to form this carboxylic acid and HCl, that is hydrochloric acid. For example, we are going to convert this acetyl chloride, that is CH3COCl, into acetic acid. Now here this H2O, we can write this H2O as like this HOH. Then from this removal of this HCl takes place, and this OH is replaced by this chlorine to form CH3 C double bond O Cl plus HCl. To form CH3 COOH plus HCl. This is acetic acid. Now we are going to see second reaction from acid anhydride. Now acid anhydride is formed by the reaction between two carboxylic acid. That is, when one carboxylic acid is treated with another carboxylic acid in presence of phosphorus pentoxide, hit this reaction mixture. Here intermolecular dehydration takes place. That is, H2O is removed to form RC double bond O C double bond O R. This is acid anhydride. Now from this acid anhydride we are going to prepare the carboxylic acid. Now here also, when this acid anhydride is hydrolyzed by using water molecule, then here breaking of this bond takes place like this. And this RC double bond OH is formed, and this RC double bond OH is formed. That is, here formation of two carboxylic acid takes place. RC double bond OH. Two molecules of carboxylic acid are formed. For example, now this is acetic anhydride. When this acetic anhydride, this compound is acetic anhydride. When this acetic anhydride is treated with water molecule, it undergo hydrolysis. Now here also hydrolysis is carried out like this. Breaking of this bond takes place. Here this RCO is replaced by this hydrogen atom, and from this CH3CO, OCO-CH3 is replaced by OH group to form two molecules of CH3CO OH. This is acetic acid. By using these compounds, we can prepare aliphatic as well as aromatic carboxylic acids also. Only we have to take here C6H5 group, then we will get benzoic acid, and if we take here C6H5 and here C6H5, then we will get benzoic acid. Next method for the preparation of carboxylic acid is from ester. Now, when hydrolysis of ester is carried out, then formation of carboxylic. When hydrolysis of ester is carried out, formation of carboxylic acid takes place. Now, here hydrolysis of ester is carried out by using acid as well as by using base. Now, first we are going to see acid hydrolysis of ester. Now, this is ester, RC double bond O, OR dash. This ester, when it is treated with dilute H2SO4 and hydrolysis is carried out to form corresponding carboxylic acid. Now here this H2O, that is HOH, can be written like this. Here breaking of this bond takes place and formation of alcohol, and this hydrogen get replaced by this R dash to form R C double bond O OH plus R dash OH. That is here formation of two molecules takes place. One is carboxylic acid and second is alcohol. For example, this is methyl acetate, CH3CO OCH3, methyl acetate. Now when it undergo hydrolysis in presence of dilute H2SO4, then here formation of methanol and acetic acid takes place. Now here this CH3 is get replaced by this hydrogen atom, and here we get CH3COOH plus CH3OH. This is acetic acid or ethanoic acid, and this is methanol or methyl alcohol is formed. Now we are going to see alkaline hydrolysis of ester. Now here this ester RC double bond OR dash, when it is hydrolyzed by using alkali like NaOH or KOH, that is sodium hydroxide or potassium hydroxide, then it undergo hydrolysis to form, look here, breaking of this bond takes place, R dash OH is formed, and this R dash is replaced by this sodium to form R C double bond O and A plus R dash OH. Now here we can write this R dash OH here minus R dash OH, and now here this compound is sodium salt of carboxylic acid. This sodium salt of carboxylic acid then undergo again hydrolysis, that is addition of water molecule is carried out in presence of concentrated HCl or H2SO4. Then here this RC double bond OH is formed, that is from water molecule this hydrogen get attached to this oxygen atom, then this OH get attached to this sodium, form RC double bond OOH plus NaOH. This is carboxylic acid. Now here in first step, this is two-step reaction. In first step, ester undergo alkaline hydrolysis by using NaOH or KOH to form this sodium salt of carboxylic acid. this compound, this sodium salt of carboxylic acid is nothing but soap. Soap, that is saban. It is nothing but soap. That is, here formation of soap takes place. Therefore, this process is known as saponification. This is saponification process. And this soap then acid hydrolysis get converted into carboxylic acid. Now we are going to see the example. When methyl propionate, now here there are three carbon atoms, CH3, CH2, C double bond O, OCH3, methyl propionate. When this compound undergo hydrolysis in presence of NaOH or in presence of aqueous KOH, then here breaking of this bond takes place, CH3OH, and this CH3 get replaced by this sodium to form CH3, CH2, C double bond O, O and A minus CH3OH. On arrow write down minus CH2OH. That is, methanol is also removed, and this compound is sodium propionate. This is also soap. And this sodium propionate, when undergo hydrolysis, that is addition of H2O in presence of concentrated HCl, then here formation of CH3, CH2, C double bond O, OH plus NaOH. This is propionic acid. In this way, we can prepare aliphatic carboxylic acid as well as aromatic carboxylic acid by hydrolysis of esters. Next method for the preparation of carboxylic acid by using alkyl benzene. In alkyl benzene, alkyl group is directly attached to the benzene ring. Here, when these alkyl benzenes undergo oxidation in presence of dilute nitric acid or in presence of acidic or alkaline KMnO4 or in presence of chromic acid, then here formation of benzoic acid takes place. Here, in this reaction, the alkyl group attached to this benzene ring undergo oxidation into COH group. Here, the alkyl group is converted into carboxylic group. Now first we are going to see example first, toluene when it undergo hydrolysis. When this toluene undergo oxidation in presence of KOH, then here first formation of potassium benzoate takes place, that is C double bond OOK. Here negative charge, here positive charge. This is potassium benzoate. And this potassium benzoate will undergo acid hydrolysis. Then you will get benzoic acid. This is benzoic acid. Then second example, this is cumene, or it is also named as isopropyl benzene. Or we can write the IUPAC name of this compound. Here there are three carbon atoms in straight chain. At two position there is phenyl group, therefore it is 3-phenyl propane. When this cumene undergo oxidation in presence of alkaline KMnO4, then first formation of sodium benzoate takes place, that is COOK, positive, negative. This is potassium benzoate, formation of potassium benzoate, and this potassium benzoate will undergo hydrolysis, acid hydrolysis carried out to form carboxylic acid. This is benzoic acid. In this reaction, regardless of number of carbon atom present in alkyl group, this alkyl group which is attached to aromatic ring is directly oxidized into COH group. Only tertiary alkyl group does not undergo oxidation into COH group. Primary, secondary alkyl groups undergo oxidation into COOH group. Fifth method for the preparation of carboxylic acid from alkenes. Now here, when alkenes undergo oxidation, it gives carboxylic acid. Now here, oxidation is carried out by using alkaline or acidic cheminophore. Now here, first example we are going to see C6H5CH double bond CH2. Name of this compound is phenylethene. That is, ethene group is directly attached to this benzene ring. That is C6H5 group. Or it is also named as styrene. Common name of this compound is styrene. When this phenylethene undergo oxidation in presence of acidic cheminophore, then here formation of C6H5 COOH. This is benzoic acid. In this reaction, this C double bond C group is oxidized into COH group. Now second example, this is cyclohexane. 6 carbon atoms are interchanged and there is one double bond, therefore it becomes cyclohexane. When this compound undergo oxidation, then here formation of this compound takes place. Now here dioic acid, that is, there are 2 carboxylic groups. Breaking of this bond takes place on oxidation of this alkene to form 2 COH group. Now here it is 1, 2, 3, 4, 5, 6. That is, here it is hexane. 1, 6 dioic acid. Or it is also named as, commonly it is named as adipic acid. Formation of adipic acid or hexane 1,6 dioic acid takes place. Last method for the preparation of carboxylic acid by using dry ice and Grignard's reagent. Dry ice is nothing but solid carbon dioxide, that is CO2. Now here, when this Grignard's reagent is treated with this dry ice in presence of dry ether, then reaction takes place like this. This RMG bond breaks and this R get attached to this CO group, that is this carbon atom of dry ice, and then this bond shifts on oxygen atom and this oxygen atom get attached to this MgX. Then you will get magnesium complex R C double bond O O MgX. This is Mg complex. When this magnesium complex undergo hydrolysis, this hydrolysis is carried out in presence of acidic medium. That is, acid hydrolysis is carried out. Then here, from water molecule, this hydrogen get attached to this oxygen atom. This bond breaks, oxygen and magnesium bond breaks, and this OH get attached to this magnesium atom. This HOH bond also breaks to form R C double bond O OH plus MgXOH. This is carboxylic acid. This method is very important method for the preparation of carboxylic acid. Now we are going to see some examples. This is CH3MgBr, that is methyl magnesium bromide. When this compound is treated with dry ice, that is solid carbon dioxide in presence of dry ether, then first breaking of this CH3MgBr takes place. Then this CH3 get attached to this carbon of carbon dioxide. Then this bond shifts on oxygen atom and this oxygen atom get attached to this magnesium to form magnesium complex, that is CH3COOMgBr. This is magnesium complex. And this magnesium complex then undergo hydrolysis in acidic medium to form CH3COOH plus MgBr. Br and OH. This is acetic acid. Similarly, we can prepare benzoic acid also. Now this is phenyl magnesium bromide. When this phenyl magnesium bromide undergo reaction with solid carbon dioxide or dries in presence of dry ether, then first here formation of magnesium complex takes place. Breaking of C6H5 Mg-Br bond takes place. This C6H5 get attached to this carbonyl carbon. Then this bond 5 electron shifts on oxygen atom. Then this oxygen get attached to this magnesium bromide to form C6H5 CO O Mg-Br. This is magnesium complex. And this magnesium complex when undergo hydrolysis, that is addition of 40 molecule in presence of acidic medium, then you will get benzoic acid, that is C6H5COOH plus Mg-Br OH. This compound is benzoic acid.